Agenda for this talk. Do an intro, sort of setup. Maybe everybody has their own reason for being excited about large language models and artificial intelligence right now, but I'll give you mine and my perspective, the one that we have at FSDL. And then we'll go through what it takes to get an LLM app up and going in an hour. First, on prototyping and iteration, like figuring out what you can and can't do. And then deployment, getting something out there and running as an actual application people can interact with. The basic form of what we put together and what I describe in this talk will be available for you to interact with during the event. And so we'll see what that looks like. And then we'll talk about what comes after that first exciting hour of quickly shipping, and explain why there's, 10 more hours of talks after this one. All right. So to introduce why this is a particularly good time to be thinking about artificial intelligence, I want you to imagine a world where there are disturbingly simple and heuristic computer programs that can mimic human cognitive process. They're so good that actually humans are forming emotional attachments with their chatbot therapist. There's computers that can play chess. They can write mathematical proofs. There's like this awesome result that they can pass examinations that we do in school to check people's intelligence. And, mind-blowingly, you can get investment advice from an artificial intelligence. And you don't have to be some visionary co-founder to imagine this world, because it happened in 1965. So this is a paragraph from Heuristic Problem Solving by Computer, a paper by Herbert Simon and Alan Newell that took a look at the landscape of artificial intelligence at that time. It noted that there was a level of effectiveness comparable to humans, that they could play chess, do proofs, pass school examinations, and simulate the behavior of an investment fund portfolio manager. So I, reread this paper only within the last month or two and was just shocked at its similarity to what people are doing now. So the question is okay, clearly that didn't really pan out. We've not had artificial intelligence for 60 years. So what's different this time? And I think the clearest answer is that there's one tool that can do all of those things instead of a bunch of kind of specialized tools, one for each particular task that has a mixture of human knowledge, expert knowledge, and knowledge maybe you learned from data. They're one for each separate task. Now you can just use one single tool and with a tiny amount of configuration, get it going on a new task, which is, more similar to the way that we get humans to solve tasks for us than the way that machine learning models or old school expert systems models solve problems. So language models, what are these tools that kind of changed the game and made this possible in a way that it was not before? Language models model language. That's surprisingly simple trick that is required to get this capability. And what that looks like is something like this. If a paragraph was appearing word by word and you wanted to guess the next word as it appears, you'd be pretty smart, especially if you could predict more complicated things than just conversations and chatter, but things in the midst of speaking to somebody, you might throw out maybe not a mathematical equation, but you might talk about Python. And especially if you look at written documents, there are many written documents that include these kinds of more complicated things in them. And as those words were appearing on the screen, at certain places, you were able to guess what the next word would be in a way that required your knowledge of something like Python, your knowledge of science and the physical world, your knowledge of mathematics. And so large language models are really, really good at this, guessing what the next word is going to be. And so in order to get good at that task, they get good at all of these other things, like adding numbers together or writing Python code or learning things about the physical world. And I think one of the key pieces that is unlocked by this particular path to artificial intelligence and that we're excited to be talking about and sharing in this boot camp is language user interfaces. So a language user interface is a type of user interface that's been speculated as a way to interact with computers since the very beginning. So since like the 1960s, the 1950s even. We're familiar with graphical user interfaces and terminal user interfaces as ways to interact with computers. But before the GUI came about and you could look at a computer and like interact with like a physical space that was presented to you visually, people thought, oh, maybe the way I want to interact with the computer is the way I interact with a person, by talking to them, by speaking in my natural language, be it, English or Spanish or whatever. And so there was like early work at trying to get this to happen. So a famous chatbot therapist named Eliza in the 1960s by Weizenbaum. And then, so that was just a purely language interface. But people quickly realized that if you have a language interface that at least like gets the ideas from natural language into a computer, you could also have that language impact like something that was not linguistic. So for example, like a block world, a world of like simple objects. So that was put together by Terry Winograd in the Shrdlu program in 1970. And this general idea of language user interfaces, I guess like the kind of closest that we've gotten so far is things like search engines, where you can type in something that it's a little bit Googleese maybe rather than your natural language, but you interact with it much more naturally than you interact with like Python, programming language like Python. And one of the first popular search engines, Ask Jeeves, like really presented itself as a natural language interface to the internet. And with large language models, we can make much more flexible and much more capable language user interfaces that actually, behave and process language much more the way that people expect than these older systems, which are a lot more brittle, a lot more focused on a specific, like particular example, like psychotherapy only and a very simple kind, or this block world only, this very limited world of discourse. And this also, there's this like tremendous wave of hype that I think has triggered a lot of people's like alarm bells about language models and artificial intelligence. These, in particular, people who've seen these past waves. And so I just want to get across the idea that this is something that was guessed at before it. This is something that people thought might happen if we got language modeling to work. So this is a paper from the 1990s about what problems are AI complete. What are the problems that if we were to solve them, we would consider ourselves to have developed artificial intelligence? It's kind of a slippery concept. It's named after things from classical computer science like NP-complete, but it doesn't have quite that degree of mathematical rigor. But it represents the sort of field belief about what it takes to solve this problem. And the first one on the list is natural language understanding, being able to understand natural language at a deep level. And so this combination of like really nice user interfaces, a new type of user interface, and this like long-standing goal in the field of natural language understanding is sort of the reason we have this large capability unlock with the release and open availability of large language models. So we have, things are meaningfully different this time. And that's one reason for hope, but it's also important to look back and examine like, wait, what did happen in 1966? Why didn't we end up, with artificial intelligence? Because I'm sure there are people who would have been, just as excited to share how their models worked back then. And the main thing that happened is that we sort of oversold and underdelivered as a field at that time, which led to a phenomenon known as an AI winter, a period in which people became less interested, in which funding was harder to come across for these kinds of projects. So the most prominent one was right after that big wave in the 1960s, and then there was another smaller one in the 1990s. And it's important to look back at some of the details of like how that went down to understand how we can avoid that this time around. And one of the like key documents of that time is this report by Sir Richard Lighthill for the British government. He was a mathematician. He got interested in this whole artificial intelligence thing people were doing. So he looked into it and he decided it was like a load of nonsense and wrote up his feelings about it and convinced the British government, the British public, and like eventually, the world that this was a bad idea. And I pulled out a couple of key phrases from this report. He talks about the high hopes that were very far from having been realized, which was causing enormous sums to be spent with very little result, in particular in machine translation. And also he really noted that this money was being spent on these problems, and then it wasn't being turned into things that were commercially valuable. There's also a separate section about like research applications, but there's a lot of it about the fact that these programs were just like not versatile enough to be commercially viable, and that meant that this was like a bad investment of public research money. And so to avoid another AI winter coming up in the 2020s, we need to build actual products that people value. We need to build software, build tools, build things that people actually use, and then people will continue to be interested. People will continue to fund our projects and make sure we can pay rent while we're playing with ChatGPT. So the good news is that this time around, there is a lot more than just research happening. So I just went and grabbed like trending repositories on GitHub. I think this is for the last month, but looking at them, the top trending repository is the DeepSpeed library, which is for doing fast training and inference with large models, and it's particularly used with a lot of these large language models. There's also three of the rest of the top five. Well, two of the rest of the top five are actual applications that use these large language models. So the Open Assistant from Leon, that's an attempt to build like an open replication of something like the ChatGPT model from OpenAI, and a like interactive image editing tool, Painter, that uses like both vision models and language models. And then lastly, a new database technology that calls itself AI native, Chroma, for AI native embedding. So there's these are actual libraries people are building, people are creating companies around them, people are contributing to them by the thousands, downloading them and using them. If you want an even faster fire hose of like things people are building, you can check out Hugging Faces Spaces, which is regularly showing cool demos. I think Nat Friedman put it best in that when he said that like finally there's tinkering. So finally people are actually like putting things together with these models that are these like useful little toys or simple demos, or something like that makes for a good like tweet thread, or like an afternoon playing around with an image generation model or whatever. But the bad news is that the gap from like a demo like that, something that you can put together like fairly quickly and like use in certain cases, the gap from that kind of demo to a product is really big. Even when you're building something with a product orientation, like when you aren't just a researcher. So for example, I remember back in the mid 2010s when people were really getting excited about self-driving cars on the basis of high quality image neural networks. There were a ton of demos of self-driving cars, like this one from NVIDIA in 2017, and it's 2023, and we still don't have like self-driving cars readily available. There's maybe a few ways to use them in very limited settings, but they're still closer to demo than to product. And that gap can be like really, really big. So the first demonstration of a neural network for running a self-driving car goes back to NeurIPS in 1988 with Alvin, the autonomous land vehicle in a neural network. So if just because you've made something that can work in a specific setting or that is like, impressive in a particular context doesn't mean that you can immediately productize that thing. And it's starting to happen. And we're starting to, the field is starting to create and release products. So probably the most famous one is OpenAI's ChatGPT, just directly productizing language modeling, which set a record for fastest growing user base, according to some analysts, maybe fastest to 1 million users, maybe fastest to 100 million users as well, faster than Instagram, faster than TikTok. So that's a good sign. Um, there's tools for coding like GitHub Copilot, Replit Ghostwriter are also popular, powered by these large language models, and also some of the tools that that we use in full stack deep learning to build our content, like Descript for editing video and podcasts, like you would edit. So the product building is actually happening, and that's good news for avoiding AI winter. And it also means that there's like kind of a playbook emerging, or there's patterns emerging for how to actually build these things. You don't have to like fully blaze the trail yourself. And so that is what we are going to cover in over the course of these 2 days. We're going to talk about a lot of the things that go into building those kinds of applications, like ChatGPT or Copilot. And in this first little like quick bit here, we're going to like just slapdash put together one of those demos. All right, so I've got to put in a question slide, but I want to pause here. Post questions in that Q&A session, or Q&A channel, and we'll get back to them. But yeah, let's dive into this sort of like process of putting together like a quick demo application. So this is, so in the past couple months, there's been a number of hackathons around the Bay Area and elsewhere oriented on like putting together quick like product demos using these tools. And so I've been attending a bunch of them and seeing what other people are doing and building stuff myself. Just wanted to walk through what that kind of looks like. So the first half hour is sort of full of like typing and iteration. It's sort of like a process of discovery of what is possible. So the kind of like takeaways here are that like rather than needing to spend a bunch of time like thinking really hard about whether machine learning can possibly solve this problem, you can just try with your application some high capability hosted model like OpenAI's model. Try them out in like a simple chat type interface first. See if you can like see what works, what doesn't work, and you'll like often be surprised by what you can get going in that simple context. Of course, that's like not what you're going to deploy, but you can at least figure out like, is this possible, and see what the like core problems you're going to have to solve are. And then you can like jump into some environment where you can do some like really quick tinkering in a programmatic way. So we'll do that by jumping into like a quick notebook environment, my preferred environment for that kind of quick tinkering, and sort of like figure out like, okay, how would I make some of the things that I'm doing in this chat interface more programmatic? And there's like a large set of like open source frameworks and tools coming out that make that easy. So first thing that I do when I want to figure out like whether I can build something with large language models is I drop into some like convenient interface for interaction. So like interface for ChatGPT is great for this. So that's usually where I start. And I think it's helpful to sort of like start off with a particular problem statement. So the problem that I have is that I want to learn as much as possible about large language models. And so I would love to be able to use large language models to help me learn about large language models. And, I'm sure there's like lots of other people who I'm connected with who also have this problem. And so I'd like to help them as well. So like just first off, I can go in and just like ask questions about language models to ChatGPT. So like it's a good idea to start with something where you know the right answer. Because at the beginning here, you're kind of going to end up simulating a lot of components of your final application in your head. You have to pretend to be a user. You have to think about how you're going to be programming this thing. You have to maybe like step in and do stuff that you'll eventually automate with a language model. So there's like a lot of pieces here, and you want to make sure that you're putting them together in the right way and getting good results. So start off with some things you might already know. So I picked like something that I already knew about language models, which is what is zero-shot chain of thought prompting. And the answer that I get from ChatGPT is not particularly good. Zero-shot chain of thought prompting is an NLP technique used to generate a response to a prompt without having been explicitly trained on that prompt. That gets some components of it, gets the zero-shot piece, but it doesn't get the chain of thought. It gives an example, a prompt like, what is the capital of France? Language model can generate a response, Paris, by recognizing the relationship. So it's like, that's not quite the right answer. It's missing a ton of additional information. And the missing piece here is that these language models are like constructed on data that lasts only up to a certain point in time, about 2021 for most of these models. And a lot of the interesting stuff that has happened in language models has happened after the cutoff of their training date. So that's not gonna. So this isn't gonna work. And the like another piece is I really want to be able to like follow up on this information. Like I want to be able to read more, not just from language models, but like I want to discover new resources. And in general, the outputs of these models include a bunch of stuff that does not exist. So for example, in a previous time when I asked about this, about where I could read more, it came up with, it suggested one paper that did exist. It also suggested a bunch that didn't exist, like how to build OpenAI's GPT-3, a step-by-step guide on towards data science, which sounds like something that might exist, but as far as I can tell, does not exist. Yeah, and I don't think I'd want to read it if it did. So yeah, so like we have a problem here, which is that the language models like don't know like where the sources are. They can't, and there's information that they don't have, and so we need to like provide it to them if we want it to be a good solution for learning about language models. So like in this chat interface, I might pull up this zero-shot, just check. So I'm forming a hypothesis about how the language model behaves based off of like what I've read about them, what I've learned, other things I've seen online. I'm building a hypothesis about why it's like succeeding or failing. But I should check that before I go on to like trying to build up more of a prototype. So my hypothesis is that if it just had the right paper in there, then it would give the right answer. So let me just like quick look the paper that I'm thinking of up on arXiv, grab the abstract of it, and then put it in. So here's the abstract of the paper. Drop it in. Based on that abstract, what is zero-shot? So this isn't something we'd expect a user to do, right? This is something that's going to happen in our application, but we're just sort of mocking it in this early stage. So now the model gets the answer correct. Zero-shot COT prompting is a technique for performing complex, multi-step reasoning without any handcrafted few-shot examples. It involves simply adding the phrase, let's think step by step before each answer. So great. So if we can get our sources into our language model, like pulling them from somewhere, and we can ask the language model like questions with those sources in its prompt, then we can probably get decent answers. So at this point, once I've like tried something like this out, done a little bit of back and forth, maybe, then I'd hop over to something like an ephemeral notebook environment like Colab to like try out like what would this look like if I were to actually start automating some of these steps. So apart from setting things up, so the first thing is like, how am I going to interact with the language model? So OpenAI offers an API, so you don't have to be typing stuff in. And there is a Python SDK for it and a bunch of other SDKs for it. But and you can build your application on top of that, and lots of people do. They want that level of control. There's also a bunch of emerging like frameworks, open source frameworks for interacting with these models, and probably the most popular of them is this library LangChain. And in my experience, every time that I need to do something new with a language model, like oh, you know what? I could do my vector store in Redis. Oh, looks like it's not in LangChain. Let me code that up really quick. Then like a week later, LangChain adds it as a feature. So they're moving extremely fast and sort of like adding all the things that you might need, sort of serving a similar role that like framework in like React might for front end development, like just giving you all the nuts and bolts you need so you don't have to reinvent the wheel. So for example, it gives us an abstraction over LLMs where we just like call them like Python functions, which is convenient for not having to think too carefully about what's going on. Yeah, hot tip. Like when you're doing this like prototyping phase, which you'll run into is that like just displaying this text is really challenging. One of my favorites is in a notebook environment, you have things like Markdown for rendering. Yes, all right. So we've got a place where we can run the language models. We can see what their outputs look like. So now we need to do that process of like finding information and bringing it into the context. So there's at this point you could think, oh gosh, I got to go and like come up with a way to like scrape information from archive. For me, my white whale was I spent a very long time trying to figure out the YouTube SDK. But it turns out there's almost always a Python library for scraping you need to do. So just like pip install archive and import it, and you're ready to go. You can pay for summary. And so maybe that's what it's going to look like in our final application, maybe not. But first, quick check, if we just grab that summary and run it into our language model, do we still get a good answer? And zero-shot chain of thought prompting, multi-step reasoning, single prompt template. Okay, looks pretty good. But the answers are always going to be in the summary. There's probably going to be answers elsewhere in that in the paper. And now we run into a problem of like, how do I get information out of the PDF? Luckily, not only is there a Python package for like getting information out of PDFs, it's also built into LangChain as a document loader. So there's a lot of these like core pieces that you might need for lots of different applications already built in with lots of different options. So I just picked a simple PDF loader. And so again, the information for this question is just in those first 2 pages. So let's like grab it out and see if we get the right answer. And again, the model answers correctly. So then the last piece is like, how do we solve this problem at a larger scale? Like, how do I find, like, I have a bunch of information. I want to like search through that and find the relevant stuff. We'll hear a ton about all the different ways to solve that problem in Josh's lecture on augmented language models. But for now, we'll just do what's become popular in the LM community, which is using embedding search. So turn documents into vectors and check the similarity of those vectors. So, all these things also built into LangChain, split things into pieces, turn them into vectors, and then check like which of these vectors have content that's similar to this question. So it's a heuristic, much like many of the other heuristics like keyword matching. You can definitely get a lot better than this, but maybe this will work for our simple example. This has information, zero-shot COT, a zero-shot template-based prompting for chain of thought reasoning. So it got that the first thing returned has our example in it. And we could continue like prompt fiddling, like solve this problem. Like, how do we pick those things and put them in there? How do we get the language model to like cite its sources? But at this point, once I've like got the kind of core going, I go out and I check like Twitter and LangChain to see like who else has built something similar. And you'll often find that there's like a really good chassis to jump off of. So this QA with sources thing that I'm doing here kind of emerged as a bit of like a pet store API or a to-do list app kind of introductory example. So there's tons of options available out there, and we'll just run with LangChain's default example. And just like once again, we get something that's like callable, like a Python function, and uses a language model under the hood. So now we've got our source citation and an answer coming out of our language model. So we've like demonstrated the feasibility here, and like we just got to turn this into something that can actually be used by people and at a larger scale. So I think the first, let's jump back slide. So that's your like first half hour. And again, it's like the ability to like prototype and tinker has not been really part of the like machine learning workflow until recently. Like when I started, it was like, okay, first you need to define your task really carefully and then collect gigabytes of data. And then only then can you like try and figure out whether it's feasible or not. And then once you figured out whether it's feasible or not, you can try and do like, like try and build a user interface around it. So this is what's most different now, what's most like unlocked by the new affair. Okay, so then lastly, so then like once we've got that like basic thing going, it's time to like put together like an MVP version of that that's deployable and ship it. And this like the key like building a demo is easy. What makes building the actual application hard is like figuring out what's actually useful to people, not just yourself, people like you, but maybe like a broad collection of users. And so like your priority should be like putting together a user interface where you can start getting feedback from users like as quickly as possible. The like other major like unlock here coming not from the machine learning world, but from the broader software engineering world is it's like much easier to get started now thanks to like all of like amazing tooling for like cloud native or cloud based development. So long, like this makes it super easy to get started, makes it super easy to scale when you finally like blow up on social media. Just like make sure to limit your spending. So like, all right, so we have this working Q&A bot. It answers questions about stuff. Like how can I turn that into like a user interface where I have some like readily available users who'll try it out and give me feedback? Well, Full Stack Deep Learning has a Discord where we have people from our past classes. So like, let's build like a quick Discord bot. And this is, popular enough of a way of building things with large models that it's what Midjourney, it's the primary user interface for Midjourney, the like text to image model. So, start here, finish anywhere. So what is that like? How do we put something like that together? We're going to need to add some way to get a hold of data and put it into storage. So we're going to need like information, lots of all of our different sources, put them in storage. And then we need a way to like quickly index them. So that was like pull out the relevant information. Then we're starting with this like very early version of the application. We don't want to have a bunch of servers on all the time. So we want some serverless backends to communicate with a language model, communicate with our various persistence solutions. And then like that's where some of the heavier lifting happens. And then we have a lightweight Discord bot server that's like, relatively cheap to run the whole thing. And so there's like potentially like lots of different stacks that can solve this. Particular collection, I'm going to use in this demo application is like OpenAI to give us our language models, Pinecone to give us quick search over vectors, MongoDB is our data storage, just because we're moving fast here. Schema's just going to slow us down, at least for now. And then for both our serverless backend and for our like loading of data into our data storage, we'll use Modal, which provides just like kind of quickly scalable serverless compute for data science. And then for that Discord bot server, we can use something like AWS. Lightweight EC2 instances are free for the first year. So like make a new Gmail account, like sign up for AWS, get a new credit card, and now you have a whole year of free Discord bot service. So the not really enough time to go through the full details of how this is set up, but I did want to just give one plug for why this like why did I call out like cloud native tooling as something that actually accelerates this process? The bottleneck I repeatedly ran into, Eugene Yan mentioned running into this, is like it's always the data processing, right? Like that's always the part. It's like heavy and slow and fiddly in the details. And so I ran into this problem where I had like a couple of hundred PDFs that I wanted. So the primary source for this is my lit review about 300 models, 300 papers on language modeling. it takes a long time for even a computer to read 300 PDF. And that was like bottlenecking me in development. With Modal, I can just like put a little wrapper around a couple of my functions for like loading, extracting PDFs, and then just throw it up their infrastructure and launch like 100 containers, one for each PDF. Like, why would I put multiple PDFs in a single container? Like that we're mixing concerns. Obviously, we should split this out. So you could just like quickly like solve lots of your data problems without needing like to set up Kubernetes, to like get a whole data engineering team, to like or to like pay for maintaining a bunch of servers. So like really great for small teams, which is critical in this time where we have like a lot capabilities like unlocked all at once with language model. So then like at that point, like we just take some of the stuff from that notebook, like put it into some scripts and wrap it with Modal, and so we'll talk in like a lot more detail about what this application looks like in the afternoon. We'll do a walkthrough code base of a sort of slightly more mature version of this application, so you can see what it actually looks like. But yeah, that's the basic playbook for getting something going really quickly. And so the this version of this is already running. It's in the Ask FSDL bot channel in Discord. And it's got information about LLMs, and it's also got information from our past classes. So it's got a bunch more data sources. So type /ask, and you can ask the bot in the Discord. I might do just like a quick example there. All right. All right. So our first question coming in: how can we visualize what happens behind the scenes of LLMs? Visualizing what happens behind the scenes can be done by constructing belief graphs. Okay, so this is interesting. This is an interesting paper back from like the BERT days that tried to figure out what the like knowledge base of a language model is. So interesting resource, not a bad answer to the question. Also, yes, so this bot also has some stuff for handling irrelevant questions, like how are you doing today? So yeah, you can emoji react. So just type /ask, you get this question pop up. So what is zero shot? COD prompting. Boom. What are keys to scale LLMs to billions of users? That might come in. That might be cool.
Look how cool it is that it links to a specific timestamp of a video.
Yeah. Up here. So we ask, what is the vector index and why do I need it? Yeah, so so up here it's got links not only to like papers, but also stuff from our past classes with links to specific timestamp components of our YouTube videos. So we'll see a little bit more about how that's done. Yeah, so encourage you to try this out, like ask questions in different languages and see what it does, like try and prompt inject it. I'm sure that there are ways to prompt inject it if you're familiar with that. And so just like try stuff out. We're collecting up this user data, and we'll sort of like analyze it in the afternoon. And because like sort of one of the next steps that you need to do after you put this together, one of the next steps that you need to do is like start monitoring this thing, so that you can see like how users are interacting with it, what's going well, what's going poorly, so that you can start making improvements. So that'll be the stuff that you provide will provide some interesting lessons for how language model powered applications fail and succeed, hopefully, at least once.